Hi everybody, welcome to another chapter or another session of college algebra. First thing I want to mention to you today is that we are having our test number 2 on Thursday during our regular class period. The test is a little bit long, so you can have an hour and a half to work the test. I'll release the test at 12 noon on Thursday, so you'll have to submit it, a copy of it that is, by 1:30. Okay, now there's going to be one of those problems on the test where you throw the ball in the air and it makes a parabola and you have to answer questions about it. Betty has prepared a review for you all, and she has already emailed it to you without the answers. So if you want, you can start working on that review today, including that throwing the ball problem, and that would be good. She asked me to mention that to you. And also in the throwing the ball problem, the one I've put on the test, you can factor that quadratic equation directly. You don't have to use the quadratic formula or anything. However, for graphing it, it makes the problem a little bit easier if you're using a graphing calculator. You can immediately see the graph and not have to mess around with graphing it yourself. If you do not have a graphing calculator available, there is a free program out on the internet called Desmos. I hope this is in focus here, D-E-S-M-O-S. My kids used it in high school. My son is a senior in high school, so he's still using it in his high school, which is in Boulder Valley School District. And you could just Google for Desmos and get this program up there. One of the options will say Desmos Calculator. And you can go and select that and just type in the equation that you want to graph. You type it in, hit return, and it graphs it. You will have to adjust the size of the x-axis and the size of the y-axis, just like you do for a graphing calculator. Now, if you need any help with running Desmos, I can show you in a couple of minutes. Just send me an email and we can set up a time to do a Zoom session, and I'll show you right on Zoom how to run Desmos. Okay, today's lesson is a long one. So we will look at all this material today in our session together, in our video together, but we'll take another look at it on Thursday after the test. There's a lot of information in here. And of course, none of this stuff will be on the test. The last thing that will be on the test is section 4.3, which we covered on Friday. Okay, our title for this section is Additional Equations and Inequalities. So this is related to the quadratic stuff we've been doing and the absolute value stuff we've been doing, but just some variations that can happen in these problems, including changing from equations to inequalities. We're going to start with radical equations. Look at example 1 on page 287. The square root of the quantity x plus 5 plus 1 equals x. The strategy is isolate the radical sign. So I subtract 1 from each side to get this. This is good because now the radical expression is all by itself. That means I can eliminate that radical. In this case, since I'm taking the square root, I need to square each side. When I square each side, the radical sign disappears. I just have x plus 5 on the left. On the right-hand side, of course, I now have to square the quantity x minus 1. I do that, and I say, okay, I'd like to solve this, so I'm going to solve it in the usual way. I'm going to set one side equal to 0. It turns out this one factors nicely, just like that. So I get my answers. X equals 4, x equals minus 1, right, from these two factors here. Now, in this case, you must do the check because, as I've written in green here, extraneous. Why do you have to do the check? Extraneous. That's what I've scribbled in there together. You actually can get extraneous roots from using a method like this. Extraneous just means extra. They're not really roots. Your work will suggest them as possibilities, but you have to check and make sure they are really solutions to the problem. What introduced the extraneous roots? This step right here. When we squared each side, we were messing with the internal algebraic stuff, and we changed the situation to where not only are we going to get any actual roots that are there, but we'll get some extraneous roots perhaps also. So, let me set this here. I first check x equals 4, which comes out of here. So I plug it back into the original equation here, and I get the square root of the quantity 4 plus 5 plus 1 equals 4, I suspect. Got my question mark over the equal sign. All right, 4 plus 5 is 9, square root of 9 plus 1 is 3 plus 1 is 4. All right, this one checks out. We've found an actual solution to the problem there, an actual root. Now we try the other one. X minus 1 is what comes out of this factor. Square root of the quantity minus 1 plus 5 plus 1 equals negative 1. Well, I have a question mark there, and I go through the steps, but actually the square root, well, it could work, theoretically. Okay, minus 1 plus 5 is 4. Square root of 4 plus 1 gives me 2 plus 1 gives me 3. No, it does not work. This is a case where we have an extraneous root, so we reject it. And the solution to the problem is 4. So, to review, when you have a radical sign in the equation, you want to isolate that radical, square each side if that's what you need to do. If it's a cube root, then obviously you need to cube each side to get rid of the radical sign, so on and so forth. And then once the radical signs are gone, you would solve it in the ordinary way. But you have to remember that you must do the check here. Right? That's something new that we haven't seen before. Okay. With that information, I think you're ready to go try one. Go to problem number 2 on page 298. Square root of the quantity 3x squared plus 4 minus 2x equals 0. Pause the video right now, work that problem out, and then we'll come back and see how you did.